Alright, time for another draftphysics.com. Debatephysics.com also, but just cannot get anyone to participate in any kind of discussion back and forth on these particular issues and subjects. They just won't do it. No one. They won't do it for money. They won't do it for the love of argument. They won't do it for just uh, the challenge of testing their ideas. Just won't do it. Can't get anyone to participate in any kind of reasonable way. Any kind of statement made, they just won't argue it. So anyway, this was a Institute of Art and something or other. Fun. It's just anyway. They always invite Sabine Hassenfelder, and then they have two other morons on the panel, and they do this jibber jabber, and they don't say anything. And so this one was interesting because they're all admitting that this conflict between the gravitational theory, the relativity theories, and their notion of gravity as not a force. It's some sort of magical bent geodesic thing. And the rest of physics, okay, which they have some kind of real forces, but they're all superimposed, entangled mush, okay? So they call it quantum mechanics as if it has something to do with some sort of elemental quantum of energy, but they've totally let go of that, and now they have particles that just poof into existence, forces poof into existence, everything just, it's all a bunch of wooey crap. And so I would just say their garbage theory doesn't mesh with their rubbish theory or their trash theory, which you could argue is the standard model. So the trash and the rubbish and the garbage all doesn't it does it doesn't bake into anything, and they're surprised that they can't bake this into anything edible. uh, and obviously it's not a surprise, because it's all wrong-headed. So in some points in the conversation they admit they need a new starting point. They almost say something like that, but then they'll vacillate and run away from that idea and say they have to save the kernel of this is correct and the kernel of that is correct, and they just need some little tweaking, and they just argue, saying absolutely nothing. And then in the end, they're asked a simple question: what is gravity? And none of them say, it's obviously a force differential. It's obviously a potential differential, okay, created by some phenomenon in space. That has something to do with the massive objects, some kind of vague notion, but nothing real. So I'm just going to point out, this is, science isn't as complicated as they made it. The simplest questions almost answer all the more complicated questions once you've established a starting point, you could argue. That it's just one thing connects to another thing, connects to another thing, and then the challenges are, you have to, there's a few pieces you have to think about. What the hell is that? I didn't ask for that. I didn't ask for whatever this is either. All right. So the first thing I would argue, one of the huge gives away, okay, that there's the universal facts, let's just say, is that it's a push universe, okay? That there is no such thing, okay, as an elemental pull. Okay, if I drew something and I said, okay, how do I make a pull? Okay, here's another thing. How do I make a pull between these two objects? Hey, there's nothing. You can't. This one says so. Come to me, Come to me by the magic come to me powers. No way. But push, you can understand, and this thing moves and it hits this thing and it pushes it. So then you can understand, okay, this thing moves, it hits this thing, now this thing moves. And we see that in a Newton's cradle. You see that whatever this one has called movement, it can give it all away to something else, and then it has the movement. It has the condition, okay? And it just seems kind of obvious that you can figure out, I think, okay, that things move because they're pushed, not because there's some pull thing in the universe. So the universe starts with the idea that there's two, just push. And then I could just say, well, I don't know if I have to go into more. I mean, if you have to explain any further, I could argue that, look, if I was going to move, if I was going to pull on this, how could I pull on it? I have to get behind it and push it like a doorknob. I mean, you can just sort of understand that everything kind of requires you to push on something Ultimately, I have to push on something, and I can create a circumstance for the rest of the stuff, but I have to push on some part of this, and then it ends up, in a sense, causing pushes to push everything. And the other part that's kind of intuitively easy to understand is you could sort of understand that the absence of a push, that is, if I had another object, okay, and it was coming from the other side, all right, and these two things were going to hit this thing and push on it, that they could have equal force, and this thing wouldn't know there was any problem. It would just stay where it is. But as soon as I release one of them, as soon as I take away one of the pushes, it'll look just like a pull. Right? The absence of a push, right, will look like a pull. So if there was a pull here, and I made this pull go away, push, then obviously, the existing other push that was already there, push it, and there won't be a pull. So it's sort of an easy way to sort of understand that. All right, so maybe we'll jump ahead a little bit. I figured that would happen. Yeah, it's just not going to let me make this video. Alright, back. Alright, so, I would argue that this is, these are just like, you could order these as facts, okay? You could just say, okay, fact number one, it's a push universe, okay? So, there's just no reason to think otherwise. And then I would argue that we know it's the speed, okay, of force, okay, not the speed of light, the speed of force, okay. All the forces move the same speed, all right. So magnetism, electricity, light, and gravity, they all move the same speed, and all of these things, okay, that move in the same speed, they all are capable of exchanging energy. So they all are mechanisms for exchanging energy. And that's the quantizable part. So the quantum mechanics should really be about the fact that all of the stuff moving the speed of light is all of this little stuff. It's very small, very discrete, okay, affects things in this very tiny universe, affects electrons and protons, essentially, the only things that are matter. So you could say that the third fact, okay, if we were going to play along, these are the things I would argue are essential to getting any kind of theories of how anything functions right, is understanding or recognizing these simple elemental facts, that there is a difference between force and matter. Okay, so that would be the third fact is, well, I guess you just say it, okay, that there's two kinds of stuff. Maybe I'll put a two here. Two kinds of things happening in the universe. There's force, okay, and there's matter. So we have the motion of force, the fields, okay. I would argue those fields are made out of real discrete bits of something, so I would say this could be qualified with the word bits, and I would be really pleased if you could understand that. But that's really what the forces are, okay. They're not fields. They're fields of soldiers. They're fields of something, and the stuff is moving. So that would be a compound of this one. So yeah, let me just write the word matter here. So we have that done. M-A-T-T, yeah, E-R, yeah. So you have force and you have matter. So my argument would be the force is all that stuff like photons, and the stuff that's creating magnetism, and the stuff that just say it's an electric field, but it's really a magnetic field. But anyway, that stuff, the stuff moving the speed of light, including gravity. And then you have the matter, which is just electrons, okay, and protons. And the neutrons are just a composite. Okay, so this is where it gets, fairly simple, in the sense that this isn't saying very much, right? I mean, this isn't pushing logic too far to say, well, it, either there are magical forces, okay, I mean, magical things that happen where something just makes something move towards it for no reason, or it's a mechanical universe and the force stuff has to act on something to make it move. And the somethings are all this matter stuff, and the force is doing the motion. So you could argue that the force has all the motion, all right? It does all the moving, and the matter does the collecting. So I don't have some simple way to draw collecting, but the matter is dead until the force forces it. So matter doesn't move until it's forced to move. And when it's forced to move, it has the force. The force sticks to it, okay? It becomes part of it while it's moving. And that also is intuitive and, simple enough. It's not a challenging thing to say. Now, you can disagree. I'm just saying, but there's nothing in the evidence that says none of these things are true. There's absolutely no proof there's a pull magic. Push does explain it. I just take away a push and that would look like a pull. So, I mean, that does work. It obviously is the speed of force. I mean, there is no other speed for the discrete stuff. There's nothing moving, half the speed of light or 3/4 the speed of light, except for matter, and it's only doing it because the force is pushing it, and by pushing it, the force doesn't go as fast, obviously. If a force going the speed of light has to push matter, it can't push the matter the same speed it's going, because it's heavy. I can't run as fast if I'm carrying a bowling ball. I mean, it's kind of obvious. I'm going to slow down. All right, and so we're heading to the 2 + 2 + 2 physics. All we have two kinds of stuff. We have two kinds of force, two kinds of matter, we could argue. So maybe that's the part that will require a drawing. Yeah, I guess I can just use the bottom of this. I can move this up. And I have lots of room. Okay, so I'd say a fourth thing is really understanding charge. And, once you've done that, I think it closes the door to all the wooey stuff. You don't need it anymore. Because once you understand this plus and minus thing. Alright, once you understand that what you're really trying to do here is duplicate, gravity, in the sense that gravity does one thing. It moves stuff towards, the thing that has gravity. And charge does the two things. It does this idea that like things attract and unlike things repel. So I guess we should put the unlikes in here. So if I could argue, and I think I can argue reasonably, that electrons and protons are all there is, elementally. And I could argue that the neutron really is neutral because it has both. It's a dipole. It's the smallest dipole. But anyway, so in all you're doing is, so you're saying, look, this is their task, is they have a simple task. You have to explain how I have these two different things, and now you have to explain why do these repel, and the like things repel, and why do the dissimilar things attract. I don't know how to draw attraction, so we just call attraction a bent line and a straight line for repulsion. And so, it took a while for me to fall on it, but it really can be done with so few steps. So all I really need to do is create an environment, right, that's full of something. Like if I fill it full of one thing, one kind of force moving the speed of light, I can create pushes, and I can push it all together like gravity. So I could actually, if you envision a box, and it has a bunch of BBs that are have perpetual motion. That is, they just bounce off the edge of the box. They never slow down. They always go the speed of light. And you could even argue that they just bounce off of the little things inside. Even in that circumstance, it works. But if they stuck, you could get even a better idea. But let's just say they bounce around in the environment, and they can't leave the environment. and you put things inside of that box full of BBs that are bigger than the BBs and don't have motion, the fact is they will move right into each other. They'll act as if they had gravity. They'll mock gravity. Okay, so you can create attraction this way. Now the trick is I can't really create repulsion this way. So one force just doesn't work. And a simple solution, since you have electrons and protons, is just to put in that field two forces. And once you put two forces in there, alright, so there's an electron force and there's a proton force. Alright, so unlike conventional physics that says there's a field for 400 different particles, I'm just asking you to believe in two fields. The plus field, the minus field, the electron field, the proton field. And with those two fields, it becomes really simple. You just have a simple two sets of rules, two kinds of interactions. So when the little bit hits, it can stick and push, or it can, in the case of the electron, if it's a red bit, it goes right through and it comes out an electron bit. So it doesn't do anything. It's invisible, except it gets converted into a blue bit. And with that simple two actions, sticking or reflecting, technically, reflecting in the sense that if this electron was already moving, right, if this one already had a little bit stuck to it going this way, and I hit it with a piece going this way, you can kind of understand from like a Newton's cradle, it's an elastic reaction, and both of them are going to end up reflecting. And so it can only collect motion in one of the two sides of a dimension. So there's three dimensions, and it can only collect motion in one of the two sides. It can only go left or only go right. It can't go left and right. Okay, it can't go up and down. Can't go forward and back. So, but it can collect more and more force in a direction. So it can get hit a few times in the same direction. And the simple truth is the more force it collects, the faster it's going to go. So it might go 10% of the speed of light when it has 1, it'll go 20% when it has 2, and it'll go 30% when it has 3, that kind of thing. So I can move electrons and protons at very different speeds, depending on how much more force I've hit them with from one direction than has come from the other direction. And so that's the simple argument here, is each one of these little bits has a straight line course, and the fact is they either stick or reflect, or they are just transferred into the opposite bit. And what the end result, you can sort of understand that it can only reflect, a proton can only reflect the red bits, and it converts all the blue bits into red bits. So what's it going to look like? Well, it's just going to end up being something that's reflecting a lot of red. Okay, all the blue is going to be turned into red, and all the reds are going to reflect eventually, you could argue. And the electrons will do the same thing. They're converting all the reds into blues, and so you can understand that they're going to look like a perfect opposite. And this is exactly what Maxwell drew, essentially, is two opposite charges, okay, that basically one's an in and one's an out, but in this case, obviously, the in and out part they both share, and all they have is this distinct difference. So the fact is when these two things get close to each other, no red bit can get to this side of this proton, so it's getting hit by a lot of force this way and no force this way, because no red bit can get here. So obviously it moves this way, and the same thing's happening to the electron in reverse. No blue bit can get to it this way, and it has lots of blue hitting it this way, so it's going to move towards the proton. So that's why the likes attract. And obviously the repulsion is made out of the fact that they're both repelling, they're both shooting off reflection forces they don't like that cause them to move in the opposite direction. So obviously there's going to be a strong tendency for the like ones to move away from each other. So with that simple solution, two kinds of force, two kinds of matter, electron, proton, charge, elemental charge, and this simple interaction, 2 plus 2 plus 2 physics, gives you all of the capacity to explain motion in the universe. Alright, so now we'll do the specific of gravity, okay, which can be semi-easily understood. So this is the part they're talking about, and they're saying they need a new theory of, or a better theory. Okay. So anyway, so the fourth thing was charge. Okay. Won't bother putting it 4. You can just understand 4 is explaining plus and minus. And the plus and minus again goes to north and south. Okay. The north and south is a tiny bit more complicated to explain because it's a pattern. Okay. It's not any more complicated than just being a pattern. And it's like if I have a bullseye with a blue center and I match it to a bullseye with a red center, you can understand those two can attract. But if I have a bullseye with a blue center and a blue center, they would repel. And that's sort of what magnetism is taking advantage of. Magnetism is happening because atoms are repelling atoms. It's not electrons and protons, it's whole atoms now. And they're polarized. That means they have a appearance. Okay. So this was charge, we'll just plus and minus. Isn't working. It's always something. All right, so that's been explained, and so the gravity would probably fit before these because it's much more elemental, but it has complications. So back in Newton's day, there was a guy called Fadio, and he ended up having a theory that was later called Lesage gravity, which is a particle gravity, what he called it, minute corpuscles, or so it created this very discrete, invisible force of pressure in the universe, and so it was basically some kind of a photon type kind of theory that there was a pressure that was pushing everything together. And the problem with it is, if the universe is full of this pressure, you would have a phenomenon called drag. And the catch is, you do. Okay, so we're sitting here on the Earth, and all the physicists will admit that electrons and protons by themselves really can't be shot to Earth. The Earth isn't going to get hit with high-speed electrons and high-speed protons. The elemental bits don't make it. You can't really shoot them. There's no such thing as really an electron gun that actually works, because the particles are dragged to a halt. They lose their momentum in space, and in a vacuum even. They will lose their momentum. All right. So drag does exist, but there's something about helium nucleuses, for example, that enable matter to travel great distances in space and not lose their momentum. And so it's just understanding that, again, you just have a puzzle to solve. Why are the small bits dragged, and why are the more complicated bits not dragged? And so, again, it's just a puzzle. It's not a critical, horrible flaw in a really mechanical theory that works very well. So Richard Feynman's kind of famous for, basically conceding that mock gravity does work, does explain gravity quite perfectly, and that its flaw is this external bit, where it doesn't work in the rest of the universe, where you can't travel through the universe if the theory is correct. All right, but I'm just giving you the simple version of it. All right, so the simple version is that what's happening to, say, the Earth, or any material body, is that all of this energy is going into it all the time. All this force is hitting it. All right, the microwaves, the photons, and all of the broken elements of photons, you could argue. So lots and lots of this discrete tiny bits of force moving the speed of light. And what happens essentially is as it travels through the Earth, it does in fact push on electrons and protons. And by pushing on them, that force doesn't get where it was going. So if I have a force coming in at the speed of light, if it doesn't hit any matter, it would end up here in a certain amount of time. If it does hit matter, it ends up here in a certain amount of time. It doesn't get where it's going. All right, it's slowed down. And the slowdown is what we might call heat, okay? Because you're going to be moving electrons and protons. They're going to be jiggling into each other, banging into each other. Atoms are going to bang into each other. And that's why the center of the Earth is molten, is because it's continuously being agitated. It's continuously being jiggled back and forth. It's continuously energy is pushing this way, and energy is pushing this way, and energy pushes this way, and energy pushes this way. And all that energy has to be used. It doesn't disappear. The motion that goes in this way and the motion that this goes this way can't be canceled. They have to be actually accounted for, and they're accounted for by this kind of motion. And that kind of motion is real in the universe, and it's essentially using the energy. And so, in fact, more energy goes in than comes out. So you can simply understand that the strength of the arrows going in are bigger, okay, than the strength of the arrows going out. So you just have more energy goes in than ever comes out of the earth at any one moment. Now over all of time it's going to equal out the same, because that heat will eventually dissipate. But the fact is, there's always a consumption that's taking place, and that consumption through motion is using the strength of the force. The force would do this if it doesn't hit anything. If it hits something, the force only goes this far. So it's obviously a change in its energy. Okay, by reducing its speed, essentially by forcing it to slow down to push matter. Now, it obviously isn't slowing down, it's just being obliged to carry something that's slowing it down. Alright, you could argue. Now, that simple explanation works. Okay, it creates the inverse square law, kind of perfectly explains gravity. You have the elements right in front of you. I mean, you know right now cell phone calls are going right through you. You know all kinds of radiation is hitting you. Cosmic rays, X-rays, ultraviolet, microwaves, all kinds of stuff is hitting you all the time. And the fact is, all that stuff you do know also carries momentum. That if you get hit with enough of it going one way, you know, and I don't have any coming the other way, that I'll be moved by it, I'll be pushed by it. Fact. Photons carry momentum. The little discrete bits carry momentum. The forces carry momentum, and they will impose it on electrons and protons. So the key thing to understand is that gravity is a nuclear force. It's really affecting electrons and protons. Those are the little mass bits that are sitting there in their charged environment. Now, the charge is irrelevant, because obviously, you know, just as much blue stuff as red stuff is going in and coming out. So the charge part doesn't have anything to do directly, okay, with the fact that there's less coming out than went in, but it's certainly elemental to the basic function of why electrons and protons move, and their movement is what's consuming the force. And so you're sitting right now in a force differential of 9.8 meters per 1 second. So every 1 second, the force is giving you enough energy to go 9.8 meters per second. But the fact is, the ground's stopping you from moving, so it's pushing back with the same amount of force, and so you can't penetrate this surface, so you can't absorb that momentum. The momentum is rejected because the counterforce causes you to jiggle on the surface of the earth. So over time, whatever you're supporting yourself with, your feet or your butt, you're going to feel the fact that it's fatiguing, because it's constantly having to deal with the earth pushing back, the earth pushing back, the earth pushing back, the earth pushing back. So your body is actually being forced to oscillate in the force differential. You impose on the earth, and the earth rejects the imposition, you could argue, and restores you to your previous circumstance. It stops your motion and puts you back where you started, and then you're pushed again, and then it rejects it and it pushes you back to where you started. That simple explanation works. Okay, so again, it's a nice, easy model, and again, the only part of this model that's broken is the idea that, well, if I'm traveling through empty space, I'm going to crash into more of this force coming towards me than pushing me from behind, and therefore I'm going to lose my energy. And the way you get around that is another, I don't want to get into all these complications, because it's a drag argument. So when you put an electron, proton, and an electron together, you could sort of understand that this, and if they gave it motion in this direction, you could sort of understand that this object could never feel any force, coming this way, because the red force is going to reflect off this object. The blue force is going to get converted, okay, into a red force and then back into a blue force, and so it can never see any red force. So any momentum this object has, there is nothing stopping it. There's no counter force that it can see. And so obviously for all the drag this one gets affected by, this one overcomes all of it, because it just keeps pushing forward because it can't feel any force against its motion. So that's an explanation for why a helium nucleus, that contains these components, is able to travel through space at a very high velocity, and elemental electrons and protons can't. Alright, so again, you have lots of good reasons to say, yes, this simple explanation works. It's a three-dimensional universe. That we don't need frames. We don't need some idea that there's anything called time that's bent. Time is just a function. There's 3 dimensions. They can be simply illustrated as being right angles to each other. I can make 3 dimensions. I can't make a 4th dimension where it's a right angle to all the other dimensions. I can't do that. Time isn't a dimension. It's just a function. Sabine Hossenfelder calls it a 4-dimensional, what's the word they use? Oh, I don't remember. Anyway, but it's all their complex math where they've turned something as simple as 3-dimensional space with real distance in it, and perverted it into nonsense. So gravity could be very simple, very elemental. Charge can be very simple, very elemental. The idea of force existing isn't hard to imagine, that photons are real, that they're made out of real quanta, real bits of stuff, and that so all of that carries the information. So all these people that talk about moving information, well, that's just all it's doing, is carrying a volume of it. I can push my hand forward, and you could imagine if there were a bunch of little bits in front of my hand, that I would collect them all and shoot them at you. If I stopped I could collect them all, and then when my hand stops moving, all of them are still moving, and they go crashing right into you. And you can understand that if I pull my hand backward, nothing can reflect off of it. So if I did this really fast, I move my hand backward as fast as the little bits are moving, none of them could hit here and bounce. So this becomes invisible. So you can understand that in a field of little bits, you can basically push and pull, in the sense that the pull is going to be nothing, and the push is going to be twice as much, or 3 times as much, or 4 times as much in the same space. That you'll basically take a frequency that's this big and turn it into a frequency that big if I'm pushing. And if I'm pulling, I can take a frequency that big and I may get a frequency this big. Okay? I will change the amount of reflection and the collection of force by moving my hand forward and moving my hand backward. So you can think every time an electron moves inside of an atom, jiggles, that's what it's doing. It's sending a signal to the rest of the universe. The electron's a little beacon. It's a little lighthouse. Every single one of them. And every single one of them is sending a signal based on how it's oscillating in its atomic structure. And that includes the ones inside the nucleus. They're all trapped in a lot of tension, and they're all doing this. And while they're doing that, they're moving, okay? They're changing the pattern of all the energy that hits them. All the energy that hits them is either going to move at a higher frequency away or a lower frequency away. A higher density, a lower density. Very simple explanation. It works fine. And instead they want to believe in a bunch of wooey entanglements and superpositions, and things are in 2 places at once, and all kinds of crap you absolutely don't need. So I could include the 6, 7, 8, go on down the list. I guess I'll draw the general picture. So alright, so this is the 5 simple points, and you have a very solid foundation for explaining anything that takes place in the universe can be explained as involving one of those phenomenon. Okay, so what they have is they have quantum mechanics, all right, which started off very sensible as being a particle type theory. Okay, that everything's made out of quanta, some discrete bit. Okay, at a Planck length, a Planck weight, a Planck, smallest stuff, elemental, very elemental, and then they turned it into all the other woo stuff. All right, and then that, on top of that, through the mechanism of 1/2 mv squared, okay, which is just nonsense, right? It hasn't done anything. And 1/2 mv squared invented nothing. It didn't improve anything, didn't make a car, didn't make a dishwasher, hasn't done anything to advance physics at all, except provide the opportunity for them to create the standard model, okay, of a bunch of wooey, taus and cows and muons, puons, zuons, 450 different particles, antimatter, anti-energy, just crazy stuff, anti-proton, anti-electron, just nonsense. None of that is real. Those are all just assumptions and speculation. It's the way they interpret a piece of data. The data could be interpreted different ways. They interpret it as a wooey answer instead of the simple answer. So if I move a proton very quickly, they'll call it a positron. I move an electron very slowly, they'll call it, I don't know what they call the anti-electron. And there's no place for them, right? We know that the model of an atom is pretty simple, that it's held together by charge, right? That you have the electrons and the protons, and it's all about the attraction, repulsion between them that creates all this tension that holds them together. And there's no room in here for gluons and puons and quarks and all this other crap. No need for it. You don't need any Higgs boson to explain it. Charge does it. All right, so you got that built on top, and then you got Einstein's fake, description of gravity in the sense of it's a non-force. It's not made out of anything real. So the quantum mechanics has a little bit of electrodynamics in it. That's what they used to call it, quantum electrodynamics. But they've lost sight of all of that, with their superpositions and entanglements. And then the problem is the I don't know what to call it, the relativity gravity argument. Okay, so the relativity theories that are supposed to be explaining gravity, okay, at least the acceleration one. The special theory is the gravity theory, so I guess you could say special relativity / gravity. And you have the Einstein version of that, which doesn't say it's made out of anything called a force. That doesn't say it's coming from something that carries momentum. It's not any of that stuff. It's just some magical thing that creates this fake pull force. When obviously the pull thing, again, doesn't sound quite right. And it doesn't account for the amount of energy that goes in and then the energy coming out. Well, where does it go? Is it a vacuum cleaner with no bag? You have to have an exhaust somewhere. Now, as I'm pointing out, the exhaust is the heat of the core of the Earth, the heat of the core of the Sun. All the big, heavy, massive bodies are all molten in the center, because that's demonstrating the fact that they're absorbing the energy, and the effect is gravity. Gravity is an effect. The effect is you're pushing back with less force than the universe is pushing in, because of the fact that you're releasing less force, because you're using it to move matter. So mass, having electrons and protons, mean you will absorb force because the electrons and protons will be jiggled. And by jiggling electrons and protons, you use the force, and the body radiates less than comes in. More comes in than goes out. But that's not Einstein's theory. So Einstein just uses a metaphor. He uses, this idea of a bent fabric, which is just absolute silly, because you need gravity to explain why the bent fabric causes things to move down. So it doesn't really explain anything, and it's two-dimensional. It's not three-dimensional, right? So it's not really explaining anything. And it's just a magical force. It has no accountability. And the only thing it has going for it is that, well, whatever amount of gain in energy you get from a gravitational field, you lose it going out. So the amount of energy you gain going in is the same as the energy you lose going out. So at least it's circular. It doesn't make anything happen in the universe that's extra energy, because it forces you to use as much energy escaping gravity as you gain falling into gravity. But otherwise, it doesn't answer any questions at all. It doesn't have any mechanics to it. It's not mechanical. It doesn't work at all. And then it's premised on this idea that if I'm moving half the speed of light and I turn my flashlight on, that somehow the photon will in fact leave much slower than the speed of light, okay? It's not going to leave me at the speed of light, and what's going to happen is the whole universe is going to go speeding forward at the old time, and I'm somehow going to be so slowed down that I think the photon is leaving at the same speed. Just because my frame rate's going to go down. I'm going to go into a cryogenic state where every action is completely sped up. That is, all those actions outside of me are completely sped up, and my processing, my eyes are closing, then they're opening, and then they're closing, and then they're, so I'm not getting updated at the normal speed. And so the fact is, the photon isn't going the speed of light away from me. I'm changing my perception, and I'm basically in a cryogenic state where I'm aging less while the rest of the universe is flying right by me at high speed. So the whole thing doesn't make any sense. The photon is actually leaving me at the slower speed, and you're just waiting for me to figure that out. And if I go 99% of the speed of light and turn the flashlight on, then they'll argue that yes, I will time travel billions of years. Well, I didn't really time travel. I just went in. I just did the thing where you lie down by the tree and fall asleep for 20 years. I didn't time travel. I fell asleep and waited for the future to show up, because the rest of the universe did go really, really fast. So the fact is, it's just perceptual. The photon didn't leave me at the speed of light. Okay, it left me at c, the speed of light for it, and I'm the one who changed perception. I'm the one that made it look like it was leaving me at the speed of light, when in fact it didn't leave me, because I'm traveling almost as fast as it, and it took it a very long time to look like it's getting away from me at a high speed. Billions of years would have to pass. I mean, it's just a silly theory. No good reason to believe it. And again, it's based on atomic clocks. Like somehow atomic clocks can't be broken, when the whole idea of a nuclear power plant is breaking the atomic clock. Is basically saying, look, if I take a uranium atom and I put another one next to it, I've now cut its decay time in half, maybe even less. I take something that's going to decay in 10,000 years, and if I put more atoms next to it, I make its decay time 10 minutes. So obviously it's a very breakable clock. I can easily break decay time. So the idea that velocity would screw up the decay time of a isotope, that is not a reach. Atomic clocks aren't immune to being broken. Simple explanation. Alright, so I guess we'll play some of this crappy video. I mean, they really don't say anything. I just lament. I mean, first I had to do the insufferable fact that I had to watch the dull and stupid conversation about obtuse and nonsense stuff. So that was a waste of my time. But the very fact that they're conceding their theories don't work, they don't mesh, they don't make sense, the elements are hostile to each other, they're conceding it's broken, but they're not really looking for a better answer. They're missing obvious things. Push versus pull universe. Why don't you resolve that one first? Why don't you prove there really is a pull somewhere? The speed of force. I mean, the very idea that none of these physicists will ever say it's the speed of force. It is not the speed of light. It is the speed of every single discrete invisible field. Okay? That's this. Every one of them has the same speed of transmission. All of them transmit a pattern, transmit what's happening at exactly the same speed. I mean, huge giveaway, it's got to be the same stuff. The stuff causing gravity's got to be the same stuff that causes light. That's got to be the same stuff that causes charge. It's got to be the same stuff that causes magnetism. It's got to be the same stuff that causes electricity. It's all got to be the same stuff. It's all traveling the same speed. Come on. I mean, damn. That is so obvious, and it's just so disappointing that they're not even close to trying to start over and go with the basics. First, figure out all your simple things. You know, is it wet? Is it dry? You know, you're analyzing a situation. You know, there's muddy water. Is it frozen? Is it this? Is it that? Can you figure out how deep it is? Can you analyze it and figure out whether it's quicksand or not? And that's all you're trying to do here. You're just trying to solve this basic puzzle. And instead they're coming up with all these wooey answers. Are there ghosts? Are there gremlins? Are there pixies? You know, they're not asking any rational questions. It's just so tedious. And this is all in the context, right, of me saying, yeah, I'm right. And there's all these other nutters out there with really easily debunked nonsense theories that are even wooier. Okay, and so yeah, they just make every thinker look bad because they do the thinking sloppy. They don't care about tying up edges and loose ends. They don't deal with the fact that there are arguments against it and they really do have to fix it. So just, you know, it's a very difficult war to be in, the war of ideas. It's really a nasty war. Yeah, I'm still stuck in the foxhole. I just can't get any traction. Alright, so let's just play some of this crap. Alright, so the beginning is, you know, let's get past all the introduction crap. I'll let her do her little spiel and explain to you a little bit. I mean, it's, you know, they can't even explain the problem, frankly. The incompatibility. They can't even put it into real language.
Being here, it's always good to be in London. So since I'm the first to get to say something, I want to say a little more about the problem.
She's gotten so obnoxious. I mean, she takes everything so... Oh, yes, I came here to talk to you little peasants, you know. Oh, yeah, well, they gave me a free plane ticket, and, you know, they have put me up in a nice hotel, and blah, 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 blah. Yeah, she's just such a pile of shit.
That we're talking about in the first place. So we know of 4 different fundamental forces in physics.
Right, and it's just too silly, right? These aren't the fundamental, like the strong force and the weak force are the charge forces. All right, there's no strong force pushing protons next to each other. All there is an electron in between the 2 protons. You just stick an electron between the 2 protons, and the 2 protons will zoom right up next to each other. No problem. Simple fix. There is no strong force. There's charge.
That's the electromagnetic force that most of...
So again, electromagnetic, it's not the same thing, okay? I mean, plus and minus and north and south are similar, but they're not the same thing. Plus and minus is charge, okay? North and south is magnetism. Magnetism is a bigger thing. Atoms do it, okay? Charge is a small thing. Electrons and protons do it. Electricity is the small, tiny, more minute force. Magnetism is the bigger object force.
You've probably heard of. Then we have the strong and weak nuclear force, and we have gravity. And the problem is that...
And the easy point is they're all moving the same speed. So why don't we figure out it's all the same thing? Somehow the same elemental bit is doing all of this stuff. And all you have to do is, let's say again, 2 kinds of matter, electrons, protons. 2 kinds of force, electron force, proton force. 2 kinds of interaction, push, okay, and whatever you want to call transition, you know, conversion. Convert the force. That's all you need. 2 plus 2 plus 2 physics, all done.
three of those forces, the electromagnetic and the two nuclear forces, have quantum properties.
So there's no quantum properties. So this is their fake spin that isn't really spinning. They just aren't real, okay? All the experiments where they create these notions, they'll tell you what an electron does by throwing silver atoms at a target. And they're going to tell you, well, now we can see the spin of the electron. You're not seeing any spin of an electron. It's a silver atom. It's a gigantic dipole. It's not an electron. I mean, it's just nonsense.
So we have some particles.
I mean, I didn't get into the two-slit thing, but the two-slit thing is just demonstrating that we already know this is a force with momentum, and all it is a pattern at a frequency. Change the frequency, change what the light does, what the force does when it hits. So it's a tipping point argument. You want to tip something over that's in tension. The idea is it's like on a spring, and if you tilt it one way, depending on how strong the spring is, it bounces back really quick or it bounces back really slow. So if it bounces back really slow, well, then you can hit it before it bounces back, right? So a higher frequency will hit it, knock it over. But some frequencies won't work on some atoms because, it starts coming back before you can hit it again. So the energy won't be able to put enough energy in it to knock the electron out and cause electricity. And electricity is how we detect photons.
It's like electrons and quarks and gluons, stuff like this. And
So have you ever seen a picture of a gluon? Have you ever seen even a picture of a quark? These aren't things that are real. These are theoretical. They see one thing hit another thing and they say, well, what caused it to do that? And they just make up some pixie. Okay? That's it. Quark did it. You're not going to, they're never going to show you a picture of a quark.
know that they do funny things, like they obey the uncertainty principle. They can.
So again, more nonsense about obeying a principle. The principle is it's too damn small to see. That's the principle. We can't see the goddamn stuff. It's happening a trillion times faster than we can see. Okay, so it's happening before our camera's going click, 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 right? And the stuff happening is happening a billion times faster than those clicks. So obviously the pictures we're getting, it's like taking a picture of the human race and taking a picture in, 1243. Okay, and then you take another picture at 1564, and then you take another picture at 1720, and then you take another picture in the 1900s, and then you say, look, here's what happened on Earth. I mean, clearly it's not going to be a very good picture of what happened on Earth. Oh, come on. So there's no Heisenberg principle. There's no uncertainty principle. It's just a fact that we can't see the damn things. Doesn't mean there aren't real forces affecting them, and they're clearly not jumping from one place to another. There's no frickin' quantum leaps. There's no frickin' it just went from being in this place in space to being over here in space. Come on. Why would you jump to that silly conclusion? And they all have jumped to it. Every one of these people.
Be in two places at the same time. That kind of weird stuff. And then
Stupid. It's not weird. It's stupid. It's a stupid conclusion to draw. Gremlins is a stupid theory. Pixies is a stupid theory. Fairies is a stupid theory. Angels is a stupid theory. These are not clever theories.
there's gravity, which is described by Einstein's theory of general relativity, and that theory doesn't know anything
Special theory of relativity, not general theory.
about quantum properties.
It's an acceleration. Gravity is the acceleration, 9.8 meters per second. It's about the acceleration stuff. It's not about velocities. It's about accelerations. But anyway.
And this brings up the question, if I have a particle like an electron that can be in two places at the same time.
Again, this is their premise. They somehow have sufficient evidence to draw the conclusion that is so bizarre. I mean, next to the speculation on the existence of invisible hedgehogs, where on the scale of crazy does this fit? I mean, I propose the existence of invisible hedgehogs, and I proposed the theory that stuff is in two places at once. I mean, come on.
Time, and it has a mass, and that mass generates a gravitational pull.
Right, and it does it through a process, a cause and an effect. See? And it's just so obvious. The Earth is molten. The Earth is doing something. It's not just sitting here saying, I'm a mass. It is actually has a functional dynamic that's taking place. And maybe if you account for that functional dynamic, you'll figure out, well, there aren't nearly enough tidal forces to account for all of that. Okay, a molten center. I have to come up with more explanation than, oh, there's some tidal forces. Come on. It's a huge, gigantic amount of pressure. And the pressure is created by movement. The pressure at the core of the Earth is like, whatever, 368 million pounds per square inch. It's this gigantic number because there are so many electrons above any point. Any point from the center, you look up, there's gazillions of tons of electrons and protons above you pushing in your direction.
Where does the gravitational pull go? You'd expect that to also go to two places at the same time.
Right, so the theories don't match because one of them is invisible energy, a bent geodesic, and magnetism and electricity aren't bent geodesics. They have to be accounted for. They have real capacity to extend momentum to objects, so they can't make them poof. So that's the real problem. Gravity doesn't mimic them, and they don't mimic gravity.
But Einstein's theory can't make that work because it doesn't know anything about quantum properties.
It doesn't know anything about matter. It doesn't know anything about the reality of the cause of the motion. It's saying the motion is magical. It's not saying the motion is being caused by something, where the other field effects essentially are ether theories directly, where they're basically saying there is this field. It's a real thing. It exists in all places in the universe, and there's numbers in all the places in the universe where the field exists.
So this leaves us in this weird position where we just don't know what the gravitational pull of an electron is.
You don't know the weight of an electron because you measured it with the wrong formula. Okay, so you would know the gravitational pull if they measured its mass correctly. I mean, the fact is they say electrons and protons. If I take all the electrons and protons in your body right now, the mass won't equal your weight. Okay, so it's only 1%. Well, that's because they used 1/2 mv squared to measure how heavy the electrons are. If they used momentum, then the electrons would get incredibly heavy because we wouldn't be squaring the velocity term. So when they did the measurement, they would get a much more realistic number where the electrons would get much heavier, and we could fully account for the electrons and protons are actually what your mass is. That is your mass, is the electrons and protons, including the neutrons, of course. The neutrons are an electron and a proton smashed together.
So it's a really simple question, like what's going on with the gravitational field of this electron, and we don't know. And
so again, if they gave the electron its real properties, they would know. And again, the gravitational field really isn't what electrons have. What they really have is a charge. They're charged. And so they're moving into the force based on charge. But the fact is as they move, they're going to consume force. So they can't actually move unless a force hit them and is no longer going the speed of light. So their motion is a reflection of the fact that they have absorbed energy, taken it out of where it would have been.
If you ask like more technically, what's the matter? It's just that those two theories, the quantum field theories that we use to describe particles, like the electron and a couple of other particles, Einstein's theory of general relativity, they're just mathematically incompatible. If we just put them together, it doesn't work. But nature knows how it works.
So again, I hate when they do this appeal to nature has the answer. Of course, the facts exist. There are real mechanisms, is what you could argue. It's a cause and effect universe. It's an evolving universe. It has all of these elements that are obviously in it. And it just doesn't make any sense to say all of the invisible, all the invisible gremlins and pixies and all that crap only happen in this little tiny universe, and there's no fully grown pixies. It's just a coincidence that all the wacky ESP exists in the tiny universe, and none of it seemed to leak into our universe, the bigger object universe. And that nature didn't take advantage of any of it either. That evolution didn't make something that could take advantage of quantum entanglement and superimpose itself into two different places, transmit itself through trees. Why not? If electrons can do it.
So there's got to be a solution to this. And we don't know what it is. There have been many people who've tried to solve this problem. What we need is a theory of quantum gravity.
No, what you need is to get the garbage and the trash and the rubbish out of your theory. So get the stuff that's grinding in the gears, get the dirt out of this system, and then the system will work. So it's really the dirt that you're trying to avoid. You need a clean room to work in, where you start with basic principles and you don't add anything until you're sure it's not going to break something. You don't say 1/2 mv squared. You don't say something stupid like work is force times distance when obviously work is force times time.
Theory that gives properties to gravity. At least that's the way that it's normally put. But more generally, we need some way to resolve this.
Cause. You need a cause. You need a mechanism. You don't have any mechanism. And it's staring you right in the face. The mechanism is glaringly saying, I'm here, I'm here, I'm here, like a hoobie. Come on, it's yelling at you, I'm here. The constancy of the speed of light and the fact that all the forces share the same speed means it has to be the same stuff. The fact that the gravity from the sun will take, like the sun disappeared in an instant, it would take 8 minutes for us to know gravitationally be released. Because it takes 8 minutes for it to move, to get here. The signal is made out of the same stuff the light is made out of. That's what you need to understand.
Discrepancy between the two theories. And the probably best known approach to this is string theory, that most of you...
Just amazing that you would even say the words. I mean, it's so silly. Little worms, and the worms are either straight worms or circular worms. They're proposing that the energy in the universe is from the center out. So instead of creating a discrete force that creates pressure, they want to create a little jellyfish inside of every little piece of matter, and the little jellyfish is giving the matter energy. When it's clear the energy comes from the outside, that the matter is dead, and it needs the force to make it alive, to use a Leibnizian kind of argument. The force gives the matter motion.
Will have heard of. There are other ideas like quantum gravity, and then there are less well-known ones, like maybe asymptotically safe.
What's that? And less well-known among 17 elitist ivory tower shitbrains who are going to tell us what the truth is. So all this crap comes from this little collective of there's no other. What? Where did anybody elect them king? King of the truth. Where did they get elected? Where was the democracy here that said these people will tell us what the truth is? I mean, it's really annoying. It's really, really annoying that these people who have never been tested are just taking their post as elitist bitch.
Gravity and stuff like this. But so far, we don't know if any of those is correct or how we can even test them.
You're almost stunned at the argument. You know how you can test them? Is redoing the Eddington experiment from space. That's how you can test them. These aren't hard things to test. You know what you can do? You could drop 4 pounds from 1 foot and then 1 pound from 4 feet. You could test that. Okay, you could sit there and take a scale and turn it sideways. You know, this isn't really hard. You want to know how much work gravity does? Well, you put a mass on a scale. You know how simple gravity is to test? You put a mass on, you see this number, you can put a lock on here, right? Then you turn it sideways and you let the scale go, and this thing will move with the same momentum gravity caused. Yeah, that's what you do. So is that a complicated test? No, you're not interested in testing anything unless you can use your smartphone with the gremlin detector device plugged in, or the pixie detector. You just want to find pixies, Sasquatches, UFOs, bullshit. You just want to find a bullshit singularity answer. You don't want the frickin' real answer. Because if you did, you'd do these simple experiments that you never did. You might decide to prove that it takes 16 times the force to go 4 times faster. You might want to try proving that. God damn. Oh, these experiments are just so hard to find. No.
And yes, I think it's a really big problem. Now, when it comes to my personal opinion on what to do, as I just said, like, people have worked on this problem for a long time. It's been known since the 1930s or something.
Okay, so this is the silliest part, right? Because this problem has existed from exactly when people asked Newton, well, what causes gravity? He says, I told you what it does. I can't tell you why it does it. All right, so obviously this goes all the way back, okay, to the problem where, yeah, okay, we can describe the mechanism, we can describe what these things do, we can describe what a charge does, we can describe what gravity does, we can describe what a photon does. It creates a fringe pattern. Have they gotten any of the causal explanations correct? No. Every single one, they jump and leap to the silliest, craziest answer. So the simple answer to gravity is more energy goes in than comes back out. Okay, now fuck that. Let's go with wooey frames where time is warping and there's wormholes. The simple answer for why there's a fringe pattern. Well, it turns out that there's 2 surfaces and they're basically acting like light sources, and all of the fringe light can be calculated to be directly caused by those 2 surfaces. Every bit of it. So yeah, why don't we just say, hey, surfaces can screw up a photon. Is that a big surprise? No, not a big surprise. And then charge is just, again, you have to do a little bit of thinking. You have to create a positive and a negative. You have to create this idea of likes repelling and unlikes attracting. And I've given you a simple solution, okay? Really simple, really very little mechanism to it at all. You just need 2 kinds of BB and then 2 kinds of checkers inside the field of BBs, and you have the answer. So, but you haven't pursued any of this with any kind of fair-mindedness. Again, all they're doing is pursuing woo, 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 woo. Elitist, forky thing, woo. The whole fact that they keep all of this physics veiled in all of this complex matrix mathematics.
Things are definitely not a new thing. And there are lots of smart people who have spent their whole life trying to fix something that...
Yeah, so Einstein did again. And yeah, so, unfortunately, his own theory got in his way. In the case of quantum mechanics, he wanted a nice, discrete, solid, mechanical answer. But in the sense of gravity, he didn't care about a nice, discrete, solid answer. So that was the huge disconnect in his own brain, and that made him fail to be able to understand that a photon could be as simple as it is. That it's just bits of energy at a frequency.
They think is wrong with gravity. And I have a lot of respect for all those people, and if they couldn't make it work, I'm pretty sure I can't make it work.
All right, so that's the silly little, throwaway line. They're all working on it, though, and that's the Feynman line. If I can't think of it, well, you don't stand a chance. And, they haven't, again, the whole idea that we thought of everything and none of it works. Do you really think you thought of everything? I'm kind of arguing they haven't even tried to even open the book of ideas. The book is closed because if it's not in the Gremlin book or the Pixie book, or the angel book, they're not going to open the book.
Either. So this is why I think it's a better strategy to try and figure out if not there's something wrong with the quantum side of things.
Yes, there's something wrong with the trash. So it's not the rubbish, the standard model. It's not gravity, the garbage. No, it's the trash. The trash is broken. No, all of it's broken. All of it was poorly formed. All of it was way a cart way before the horses. All of it was conclusions jumped to way before they needed to be, and it all just ends in garbage. So anyway, so after they do this, at the end of this thing, the guy asked them a simple question, what's gravity? And none of them can answer it. So that was kind of funny. So I guess we'll play that.
Why is no one talking about August 19th, 2024?
Ah, fuck you.
That's the deadline. My research...
Microscopic explanation of where it comes from. So gravity is a consequence of moving information.
Okay, so that was his silly answer. Okay, let's see. Oh dear, that's still him. Let's see. I think she gave it the silliest answer.
I would probably defer to that kind of, it's a profound confluence of space and time that illuminates the nature of a very fundamental force that orders the visible and invisible.
Yeah, right. Just too silly. So this is somebody caught up in the whole LIGO nonsense, blah 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 blah. And she basically says, "I can't get out of my relativity box." So I'll keep playing it.
Confluence of space and time that orders our universe.
And as I said, I'm pretty trapped by Einstein still, right? So I think I haven't broken out of the box, although I'm open to and I want to break out of the box. Yeah.
So hilarious. Yeah, I know it's crazy. I know it sounds stupid. I know it's not really much of an answer at all. I'd like to be able to give you a real answer, but I don't have one because I really haven't thought about it.
Okay, Eric, what is gravity?
Well, just to introduce this, I mean, the way we try to understand gravity now is by thinking...
It's this simple frickin' differential, okay? It's 9.8 meters per second differential, okay? There's more stuff pushing you down than pushing you up. It's that simple. They can't say a force differential. Wouldn't that be just the same? It's just a differential in a, they could say in a bent geodesic. At least that'd be an answer. It's a differential in a bent geodesic in space-time.
About more microscopically what space and time is made of, and then we use words like information.
And space and time is made. Time is made out of something. Oh God damn it! Time is now a something. It's matter. Yeah, sure it is.
Especially also the quantum information. You have to think about things like what you have on your computer, like data and so on. But space-time is also filled with that information. And gravity...
So information is really not a useful word because information has a context for human beings. Information has to be something that has cohesion and consolidates. Makes something work better, conforms. All right. So noise isn't information, and the universe is just full of noise. It's not information.
I have this actually written down somewhere. Is then a consequence of moving information around. So it's the cost
of making noise. So you could argue that that would be at least somewhat better answer. The universe is very, very noisy. Okay, and we're in a noise differential. That's gravity. Gravity is a noise differential.
Moving information. Okay, so and that would be a microscopic explanation of where it comes from.
So it doesn't. Did they explain where anything comes from? No. Did he explain any of that? No. Just horseshit.
So gravity is a consequence of moving information viewed microscopically. That's okay. Interesting. Sabina, what is gravity?
So she's had plenty of time to think about it, right? The other two idiots talked all this little babble. She has plenty of time to make a joke like, well, it's the thing that makes the poo fall out of your butt. She could do something. She isn't going to do anything.
So I have to be on another panel later today where I'm supposed to answer the question, what's a particle?
So it's like all this is tedious to her. You know, all these fundamental, elemental subjects about the nature of how the frickin' physical universe works, which she's supposed to be a professional at doing, and it all seems like, oh, it's just so tedious. They bother me with silly questions about what causes the effects. Like somehow I'm supposed to answer questions about cause and effect. Like that's my job. Huh? No, it isn't. You know, I mean, it's just amazing.
Which is why I've actually thought about this question. I came to the answer that I don't think this is a question for science. I would say what we do in
So it's religion. I don't know. What the fuck? What the fuck? It's a simple phenomenon. It's so dramatic. I mean, everything's being consolidated into pushing into each other. It's all being compressed into each other. I mean, it's a real phenomenon in the universe. The matter bits are attracted to each other in net. Okay. By this mechanism. And they have no explanation?
sciences, we describe observations. So I can tell you what we use to describe the effect that we call gravity. We describe it with a curved differential manifold of dimension 4.
So that's the bullshit, right? Because at least Leonard Susskind would say, well, no, what I use is mock gravity, okay? What I use is a fluid, and I basically explain how it's an anti-divergence, you see. It's an anti-divergence, and the anti-divergence, you know, of the magical substance that we will illustrate as water, okay, the water, you know, basically, you know, its energy is pushing the matter. Hilarious.
That has Lorentzian signature. And to me, that's a satisfactory answer.
Okay, and the Lorentzian thing is just the way of making it so it's impossible to go faster than the speed of light. But again, you don't need anything to make it impossible to go faster than the speed of light except to keep piling bowling balls on the light. Obviously, if the light has to carry a bowling ball, it's never going the speed of light again. You can't push a bowling ball as fast as the force that's pushing the bowling ball.
That's what I would say it is. I'm just afraid that most people wouldn't understand what it means.
They wouldn't care to understand because it's not going to be an explanation of anything. It's just mathematical crap. And it's just going to describe, again, what it does. It's not going to explain how it does it. So calling it a manifold and calling it this and calling it that doesn't in any way explain what it is, how it mechanically works. It doesn't give you any capacity to model its function.
So does that mean we don't need to know what it is?
Yeah, just calculate. So that's another Feynman line, right? So yeah, shut up and calculate. Don't bother trying to conceptually understand anything because somehow the fairies and the pixies have hidden all of the instruction manuals, and so you're never going to be able to know how the universe works because the pixies and the gremlins have burned them all.
This is
Right. We just have to explain what we observe.
we accept it as
Oh, brother. Amazing. You're never going to observe a photon, so what you have to do is model the function. You have to come up with a model that explains it because you're never going to take a picture of what it does.
a given.
And clearly they already know that because that's what quarks are. Quarks are their model. Gluons, puons, zuons. All of that crap is crap they put in their model. These little things like it has, well, it's like a bat. It has wings, but it has landing gear so it can ski on the snow. And, you know, it has an eye in the back of its head.
It is something we work with to try to calculate or...
Yeah, so from a pragmatic perspective, we just need
No, I think
mathematical.
we are both saying something similar. Like we have an operational definition that we think works.
All right, so that's just amazing. An operational diff that, you know, that doesn't do a damn thing. Again, all of this idiotic physics that's spent all this money on doesn't make a styrofoam cup. It hasn't done anything. 1/2 mv squared hasn't cured the common cold. The Higgs boson hasn't fixed a hangnail. None of that crap has done anything. And they keep saying it works. It works. It works. It doesn't do shit. And it doesn't do anything to explain anything. It's not cause and effect universe. It's just a religion. And it's just this really queer, perverse one. You know, it's like the Easter Island heads. It just, ew. What the fuck? You know, you people be ugly. I mean, you know, it just, oh. This is the best totem pole you can make? Come on, you can't do better than this as your totem pole? This is your little symbol to put up on the wall, this sloppy standard model glop? Ugh. Alright, so enough. God, I just hate this planet. So yeah, I mean the fact is I fact is I have the model that is definitely should be the one the most effort is put into debunking or improving, because it's so fucking simple. I mean, how could I fake it? I mean, how could I come up with a fake model that actually does explain all this stuff and with these simple mechanisms? How could I fake a theory that fits, that works, that creates, you know, here, I'll pop this simulation up just for fun. Alright, it should be there. There it is. So you'll see these are electrons and protons, and what's going to happen when they hit, they become a neutron essentially, you know, and they'll basically stay in that condition until they meet again with something else, and eventually you'll create deuterons, is what they're called, electron proton electron, or proton electron proton, and that's the strong force. That's the stuff that allows electrons to get really close to each other, is the fact that there's a proton in between them. You know, it's that simple. And so this simple model works. Okay, inevitably over time, all of the electrons. Oh crap! All right, well that's enough of that. Yeah, okay, I pushed my luck. All right, maybe I can turn that off, and that will save me. We'll see. All right, so well, we're at the end anyway. So anyway, it's so simple. And, you know, this is, you know, it's not hundreds of scientists, not millions of scientists, not billions of dollars, not trillions of dollars. It's, you know, this is my one little effort has advanced the theory this far. Imagine what they could do with it if they really worked on it, you know. But that's not going to happen for a long time, because the science is so closed-minded. They only talk between each other. They're little elitist, bigoted pieces of human garbage, frankly. They're all too good for the rest of us. They all think they're smarter and better than the rest of us, you know, and it's just too tragic. They're not doing intelligence very well. You have to be able to, you have to be willing to defend your theory, right? Have I found one physicist willing to defend what he preaches? I've offered them thousands of dollars to defend what they preach, and they won't do it. That's not a sign of intelligence. That's a sign of weak religious coward.